Here in electronics, first we learn how these batteries can be connected, or dry cells can be connected in serial way and also parallel way. And we observed that last day what will happen if when it is connected in serial way, and what will happen when it is connected in parallel way. We just discussed about that. Okay. Now actually what we need to discuss the second part. Here the second part, that is basically how can we connect bulbs. So bulb serial and bulb parallel connection, that is a small part we have discussed about that. And also we just discussed about different type of resistors like LDR, light dependent resistors, and fixed resistors and variable resistors, which can be used to control the resistance of the circuit. When resistance is high, the amount of voltage flowing through the particular electronic equipment will be low. But if resistance is low, the amount of voltage falling through will be high. So here this is a rheostat, the variable resistance that we have discussed about. And today what we need to discuss about, actually I just gave you a small exercise, you have completed that, good. So I asked you to find out the voltage and wattage of different equipments that you can see in your home, voltage and wattage of different equipments that you can see. So here, this is what you have found. And you can see normal LED bulbs are taking small wattage, but rice cooker, electric kettle, right? Electric kettle, AC. So these are taken, and here dry iron, these are taking some high wattage. When wattage is high, so what will happen to the consumption? Actually, we learn one thing, that electronic equipments, though these equipments are not really consuming. Electronic equipments are not really consuming the power, because we know that energy cannot be killed, or energy cannot be terminated. So energy will be there forever, and we cannot actually destroy the energy. And same time, we cannot create new energy, right? So that is basically called, we learn law of conservation of energy, similar to law of conservation of mass. So like we learn about status of matter. Matter cannot be destroyed or cannot be created, but it can be converted. Similar to that, here the energy cannot be destroyed, cannot be created, but it can be converted. Here, what will happen in this electronic circuit? The electronic energy will be converted to light, heat, and different things. And we will learn some other things like chemical reactions today. Energy can be converted to some other formats too. Okay, so let's go to the sun. And here you can see light effect of the current. We just learn how energy can be converted to light. So we can just use light emitting diode or normal bulb. When electricity go through this bulb, right? When electricity pass through this bulb, it will light up. A diode is a special equipment. Diode, like we learn about diodes previously also. Diode will let electronic or let the current flow only one direction. Diode will not support like bidirectional flowing of the current. It can only flow one direction. So the specialty of the light emitting diode is when the electricity falls, when electricity flows. So this light emitting diode LEDs, it will convert electricity to light. You know, in addition to direct the voltage, it will convert electricity to light. That is the specialty of light emitting diode. Here you can see this is the symbol. The light can only fall one direction, right? It's unidirectional because it's a diode, and using that can convert. Then magnetic effect of electric current. Actually, we learned that in our previous lesson, electromagnets. When there is a coil, and when we supply power to that coil, especially this is wrapped on a copper core, wrapped on iron core. So it will be very strong, but even the coil itself will have the magnetic effect, right? We learn here So you can see this is just the coil, right? Just the coil, but here you can see when iron core is used, actually iron nail is used. So which will be powerful, the second setup or the first setup? Which will create a powerful magnet? Yes? Hello?
Second.
It is the first one, right? It is the first one. You can try this. First, just wrap a coil and test this. Nikama coil ekak otala බලන්න. Just wrap this. You can use a pen. Panak වටේට නිකන් ඔතන්න පුළුවන්. After wrapping that, you can remove the pen and just test this. And you can see by placing small pins, maybe file clips or pins nearby. When you switch on this or when you provide the power, the coil will be magnetized. Then this will be attached, but lightly, right? It's very lightly. But after that, you have to try with this setup. Use a iron nail and then wrap the coil similar to the previous one, few rounds, and then connect to the battery and switch like this. And then when you turn on the switch, so you can see this will act more powerfully than this, right? Because the magnet, like electromagnet created here, is powerful than the second setup. But like if you use a higher number of rounds, and also if you use a powerful battery, the magnetic effect will be very high. You can try to connect two batteries serially, right? Instead of one battery, you can connect two batteries serially and see what will happen to the setup. Right? Make another coil, wind it the more number of turns, like, oh, okay. So these are some experiments. First one is connect the coil to ammeter and switch one dry cell series shown, and you can see the pin coil close to the pins, right? Bring coil closer to the pins, and you can see this will be attached, and you can measure the current through this. And the second setup, you are just using a coil and checking the same. Right, in third setup, you increase the number of batteries. Two batteries are connected. You increase the number of batteries and test. And then the fourth setup, you increase the number of wrapped or here coil by winding more number of turns. You have turning. You have to use more number of turns. වැඩිපුර ඔතලා මේක බලන්න පුළුවන්. Wrap it more and see. So you have to write down the observations. I'll keep this to you because this is very simple experiment you can do at home. So it's a very, very, very simple. You can just use a coil, copper coil, maybe copper wire, and iron core, maybe nail. So you can do this. I'll keep this as this week's experiment because last week you just search about the electronic appliances, and this week you can try this and write down your observations there.
Okay.
Here, actually, in this one, I don't think the clips are there, but do I have a proper file clip? Is there, but not the other one. Let's try with the extra. Here you have one simulation with it. I'll show that. You can go to the same site that we experimented earlier. This shows the magnets and electromagnets. But this one, just about magnets, it seems. Let's see. Same time, I would like to go to this Tinkercad. This is loading. This is still loading. Why is that? We don't have that in Tinkercad. Go there. So it's still loading. Let's let it load and let's see. I'll give few more minutes for it to load and let's move to the next. Okay, so where we use electromagnets. So electromagnets are used in the places where the store wind you can see. So this is for store wind. So this is to separate from garbage if you want to separate basically metals, specific metals, but all metals are not not attracting to magnets. Some metals only. Some metals like gold, these metals are not really showing any interest or any attractions to magnets. But there are some metals, especially iron, like things, so that will attract to magnets. So electromagnets can be used in such places where you want to separate or sometimes in towing. And also, I don't know whether you have seen this fish tank cleaning. So it's not electromagnet, it's the magnet, but you can still use electromagnet, and electromagnet can be used in motor. In a motor, electromagnet can be used. In a dynamo, it can be used. In electric fans, bells, grinders, washing machine, most of the electronic equipments with this motor effect, this can be used, because inside a motor also, if you go through, still this is loading, I don't know. Okay, inside a motor, so you can see the electromagnet effect. So because motors are used everywhere, inside the motor, the electromagnet effect is there. Actually, here you can see this is kind of coil that is just wrapped around. And here you can see this is actually a illustration. This is not actually a motor, but it is showing an illustration. When this is connected, when power, or when electric pulse or electric signal is sent through this wire. So there are fixed magnets, they are permanent magnets. So in inner coil will start behaving as an electromagnet. Therefore, this inner coil will be pushed, right? So here north and south. So you know, north and north will not attract, and north and south will also not attract, right? So therefore, so actually when there is electronic here, when you provide electronic pulse or maybe current through this wire, it will create electromagnet, thereby it will be pulled by this so it will be pushed by this two fixed magnet. So that will create the rotational effects of this motor, right? If you see animation, so do I have a video of this?
And I have these two paper clips that are making contact to the two sides of the battery and will be the support for the motor winding shaft. And here's the motor winding. And again, I've only removed the insulation on half of one side here so that I could effectively keep rotation going. Okay, so now what I'm going to demonstrate is I'm going to build another simple motor where I'm going to replace the permanent magnet with an electromagnet. Okay, this is what I'm going to use to generate the magnetic field. So this is one piece of wire that I've coiled 50 times. I've cleaned the insulation off this end and this end here. The ends flow around this. I've taken a here around the second coil to support it like this. So let me go ahead and do that. So here's our, and so now I've taken and formed this coil, and again cleaned off the insulation on half of the connector here. So, okay, and it's free to rotate. Okay, so now what's going to happen is to generate our magnetic field, come up here, and through this connection flow around the wire here. So the battery is going to be connected across these two terminals here. I have connected a 9-volt battery, so now I'm going to put the motor winding in.
Okay.
Ends where the motor.
Just see the first setup. So second setup is also using electromagnet. In the first setup, you can see the battery is here, right? There are two connecting wires to the battery for anode and cathode. So you can see these connecting wires or connecting nodes are having small holes. Why the small holes? Because then you can place the coil there. This coil is going to act as electromagnet. When you place the coil from here to here, it will like transmit the current. Here you can see is using a coil, and here is using a coil, and then when the current passes through the coil, you can see it's connected to this end positive way, and the current will pass through this, and then like this, then it will be, this is the negative. Actually, this is not fixed. These are small holes, right, which will allow this to rotate. Here, this is a permanent magnet. The permanent magnet, but you can keep permanent magnet both ways. In a motor, there are permanent magnets both sides. This you can do easily. And this you can do easily, and this will start behaving as a simple motor, right? Motors are used everywhere. Therefore, that's why I said, so electromagnets, where the electromagnets are used, you can name any place where motors are used. Inside the washing machine, motor is there. Inside the fan, motor is there. Inside inside the vehicle, motors are there. Inside what else? Electric bell, washing machine, electronic switches, these blenders, all these are having electromagnets inside that. So that is magnetic effect of electricity. That electricity can be converted to light, electricity can be converted to magnet and magnetism. And electricity can also be converted to heat. We discussed that previously. Yes, especially this heater, oven, and just consider about water heaters. So what it does, it can convert electricity to heat. You can test the same thing here, same setup. By providing current to this coil, you can observe that this coil will be like the temperature of the coil will increase gradually. මේ setup එකට current එක දීලා බලන්න මේකෙම ඔයාලට බලා ගන්න පුළුවන්. මේ battery connect කරාම ටිකක් වෙලා යනකොට මේ coil එකේ රස්නේ වැඩි වෙනවා. ගොඩාක් රස්නේ වෙන්නේ. හැබැයි රස්නේ වැඩි වෙනවා. You can use this to use like create a simple foam cutter. So a simple foam cutter can be created using this effect, heat effect. Simple foam cutter. We can create that using a battery. Okay, here this one. So these are actually the school projects. These are some school projects you can try as a DIY project. What's the effect? Yes, this is the heat effect, right? This is the heat effect. මොකද මේ නික්‍රෝම් වයර් එකෙන් කරන්ට් එක යද්දි නික්‍රෝම් වයර් එක රත් වෙනවා. කොපර් එකකුත් පුළුවන්, කොපර් එකට වැඩි නික්‍රෝම් එක හොඳයි. පොඩි වයර් එකක් නම් ගොඩක් හොඳයි. දැන් මේ නික්‍රෝම් වයර් එක හරහා කරන්ට් එක යද්දි ඒක රත් වෙනවා. රත් වෙනකොට මොකද වෙන්නේ? රත් වෙනකොට මේ රිජිෆෝම් අපිට කපන්න පුළුවන් නේ. රත් වෙච්ච නූලකින් එහෙම සමාට රිජිෆෝම් කපන්නත් පුළුවන්. හැබැයි නූලකට වඩා මේක හොඳ. රත් වෙච්ච කම්බියකින් කොහොමද පුළුවන්? Right? You can try this. Now you have a lot of things to try at home this week. So one thing that you have to try is that electromagnetic field. The second thing you can try is this heat effect of electricity, because that is also a property. Okay, the most interesting thing is the last thing, that is electroplating or chemical effect of the current. This is interesting. Have you seen that? Okay, if you visit Temple of Tulprele or Dalada Maligava, have you seen the fence there? Or even in Sri Mahabodhi, have you seen the fence, that gold color one?
Yes, sir.
Is it pure gold or gold plated? What do you think? Gold plated means like it's like painted with gold. Or is it really gold, or is it painted with gold? What do you think? If you don't know, it is actually painted. It's not real, right? It's not real. It's painted. It's painted. And even the medals distributed in normal school ceremonies, gold medal, silver medal, bronze medal, these are painted. Painted is basically, you can also do this. I think you can remember copper sulfate, that blue color one.
Yes, sir.
Right? Yeah, we can use copper sulfate. In copper sulfate, there is amount of copper, right? Copper sulfate, there is a amount of copper, and here actually in this setup, 2 batteries, carbon rods, and acidulated water, or you can even use the copper sulfate one solution. So there. So then, what is done here actually? The power is provided. Carbon rod you can find from using all batteries. Used batteries. In used batteries, in the middle you can see carbon rods. You can just get that. Just remove the cover of the battery carefully. Get the help of an adult. Remove the cover of the battery and then the zinc layer of the battery. Then you can remove the fill in, and after that you can get the carbon rod from that. So then you can use, and there you can use here, actually you can see the copper sulfate solution. Here actually they have used an acidulated water. That can also be, that will show a bubbling effect, right? Bubbling effect basically if you are using acidulated one, because the bubbles are basically bubbles are formed in one rod. You can monitor in which rod it forms. So why? Because when power goes through the solution, when electrons goes through the solution, in one side the positive electrons positive value will be higher, but in the other side the negative electrons will be high. When electrons are higher, in this chemical there are H plus, those will be combined together and hydrogen will be formed. So that is one thing that you can see. So you can observe bubbles there, right? And the easiest way is this electroplating. That this is a simple setup that you can observe using the carbon rod and acidulated water. Just use acid, simple. Here, 50 milliliter beaker, dry cells, 2 carbon rod with the metal caps taken from dry cells. Yes, milliliter acidulated water and connecting wires. Clean the carbon rods using a sandpaper. Connect 2 wires to the, so you can see the setup. Then dip the carbon rods in the beaker, slid in, and bubbling of a gas can be observed near the carbon rods. So why there is a bubble? Because that is the chemical. So this will show there is some kind of chemical reaction happening inside this solution. I don't need to know what is the reaction actually, but you can see, because when there is observable change, you can detect that as a chemical reaction. Right, when dry cells are moved and both cells of wires are connected together, while the rods are still acidulated, no bubbling can be observed. When dry cells are removed and both ends of the wires are connected together, while rods are still in the acidulated water, no bubbles. That means when you are not providing the electricity, there will not be bubbles, right?
Okay, sir.
Electroplating. So this is if you find copper sulfate solution. So here actually they are using a copper plate and spoon also with the copper sulfate solution and connected to battery setups similar to the previous way. Again, 250 milliliter beakers taken. You can take a cup. Then 100 milliliter of concentrated copper sulfate solution. You have to put some more copper sulfate into the solution and mix it, right? Then add copper sulfate solution to the beaker, then connect the wires, and you have to keep this setup for few minutes, right? Then you can observe the spoon is basically not a copper color one. You can observe, even you can use the carbon rods, right? Carbon rods can also be used. Carbon rods දෙමත් කමන්නේ. ඒතකොට එක carbon rod එක තමයි copper තැම්පත් වෙන්නේ. හැබැයි මේකේ setup එකේදී then copper and මේකේ තියෙනවානේ copper sulfate here and this copper plate and spoon. Then you can see the copper will be sedimented, or copper will be in the surface of the spoon after some time. Not maybe 10 minutes. You have to keep this setup for few. And have you seen these people with a small beaker or some kind of setup? So they are in nearby jewelry shops. These fellows are there. They are doing this electroplating part. Right, electroplating. In electroplating, what will happen? So there is another metal, but a valuable metal, a kind of valuable metal will be used to paint the other metal. That is what the electroplating is. Right, that is the chemical effect. Okay, let's see that also. Okay, this is the copper sulfate one, and key is used here. And we have another one. Okay. Yeah, this one is good. In Sinhala, this is called Vidyut Loha Lepane. විද්‍යුත් ලෝහාලේපනය කියලා කියනවා.
Word tune is your rewriting, rephrasing, rewording. That's the Alidocious Chrome extension. Hi, in this and an electroplating copper sulfate solution.
So here actually she is also using copper sulfate solution.
Negative terminal of this battery. Now I'm going to connect this copper strip to the positive terminal of the battery.
Right. Remember that the copper one should be, the copper strip should be connected to the positive, right? The negative, because electrons, the negative rod is what we are going to plate, right? Otherwise, this will happen the reverse way. So the positive edge is connected to the copper strip and negative edge is connected to the metal that you're going to plate.
Making sure that it does not touch the key. Now, as soon as the copper strip and the key are both in the solution, an electrical circuit is formed and current is flowing. Electrolysis is now happening. Copper ions in solution are attracted to the key and deposit copper on it. Meanwhile, an oxidation reaction is happening with the copper strip to create more copper ions in the solution. After about 20 minutes, here is our result.
Here, this is the result after 20 minutes. Can you see the key? Key is now, right? The copper is in the key, so you can see copper, like copper-like key after some time. That is what the electroplating is. The gold plating, like also can, but gold is a bit expensive. Therefore, like you can try with copper, gold, silver, all these things can be used for electroplating. Okay. Then I think we have come up to this, and we didn't see the battery bulb serial thing. So let's finish that with. Oh, still this is loading today. Why don't? I don't know why this. You can try these things. I just wanted to show this because this loads quickly, but today for some reason it's very slow. So let's you can try this. You can just try this, the electromagnetic effect. But I thought that will load, but still it's on the way for some reason. No. Let's check with the normal simulations like DC kit. Still those similar, it loads. The other one takes time, but this loads. Okay. So let's see the battery serial and the bulb serial and the bulb parallel connection. The first one I'm going to connect two bulbs serially. The second one I'm going to connect two bulbs parallelly to the same battery. Actually, here I'm using a 9-volt battery, and using a wire to connect this, and using a wire to connect this one to this one, then a wire to connect this one to this one. Actually, I'm using a switch. Okay, when I turn on this, you can see two bulbs are turning on. Actually, positive edge of this bulb need to be connected to the battery, and the negative edge of the bulb need to be connected to the positive edge of the other battery. Right then, so if you use LEDs, you need to do the same. So let's get some LED. Let's have two LED bulbs and a battery. 9-volt battery. Oh, 9-volt is let's use a coin cell battery because 9-volt is like too much for this. LEDs are small. So let's connect the positive edge of this to here. Then the negative of this to the positive of this. Right? Then a switch is needed. Use side switches. Okay. So let's wait first. When I turn on the switch, you can see it's lightly. Let's use another battery. Battery is not enough, seems, because it's sharing the voltage. That happens, right? It's sharing the voltage. That is why we cannot light up both I just want to increase the voltage of the setup. Therefore, I'm connecting by batteries. Positive to negative means battery serially connected. Serially connecting battery and serially connecting the bulbs. Let's turn on now. Now you can see both bulbs are turned on. Both bulbs are turned on. And if you measure the voltage using a voltmeter or multimeter, let's measure this. So battery from this, that's the positive, okay, positive. Not the positive. So if you measure the voltage from here, to here, right? When you measure the voltage, you can see it's getting 2.38 volt. And if you measure the voltage of the other one, so it will also get the similar voltage. It will also get a similar voltage. 2.3. And if you measure the voltage of both, actually battery provide closer to 5 volt, 4.7, but it will be shared by the serially connected bulbs. Right here, the voltage provided by the battery will be shared by the serially connected bulbs half. But if you connect the batteries, if you connect this parallelly, what will happen? So let's connect the bulb now and using a wire. Now both positive edges, I'm connecting them together. The battery and wire from here to here and another wire from here to here. Then connecting them together from here to here using a switch. Okay, you can see the bulbs now take more voltage. It is brighter than the previous setup. So what will happen here? If you measure the voltage, here one bulb will get 9 volt. But here, if you take the measurement, one bulb will get only 4.5 volt. If bulbs are connected serially, bulbs are connected serially, what will happen? It will share the voltage. Voltage will be divided by the number of bulbs. If both bulbs are equal, you can divide the voltage by the number of bulbs. And if bulbs are connected parallelly, all bulbs will get the same voltage. Right? But here, because of the brightness and all, this battery will be drained soon. So this will be consumed, this will be converted. This will be the electricity will be converted to light very soon. Okay, I hope that we have covered everything in the lesson with that. You can do the experiment and see. Here you can see there are a lot of questions coming from that area. You can create this setup and see. Right? Yes, you can just do this experiment with the tool that I have provided and answer the questions. Do this at home. And with that, we are finishing the particular chapter. The next chapter is about main biological processes in plants. I'll be starting that next day. Okay, then good night. See you.
Okay, sir. Thank you, sir. Good night, sir.